In our last chapter, we focused on our solar system, the planets that revolve around our sun. But in the final chapter of our semester, we're going to look at all of the other stars that are making up the rest of our universe, not just our sole solar system. But in order to look at the other stars that are out there, we have to be able to classify them into different groups. And one of the things that we use to classify our stars is its stellar luminosity. This is basically how bright or how luminous the star is. If you look at this image, you'll notice that some of the stars are so bright that they have kind of like a cross-like shape of a glare coming from them. And then other stars aren't anywhere near as bright and don't have that glare. So when we're trying to measure the luminosity or the brightness of a star, we can measure it in two ways. The first is called apparent magnitude. And this is just how bright a star looks from Earth. But if we have objects that are at different distances from Earth, they're going to appear to have different luminosities even if they actually have the same, due to the differences in their distance. So what we use instead is we like to measure its absolute magnitude instead of the apparent. And the absolute magnitude is the actual brightness of the star. Here, when we calculate it, we're going to put in the distance between the Earth and the star into that calculation to figure out exactly how luminous it is. But one thing I want to mention on this slide is exactly what a light year is, because until I started teaching this course, I didn't really understand it. Based on the word year, I thought it was time, but a light year is a measure of distance. And it's the amount of distance that light travels in a single year. So a light year, again, it's a distance, and that distance is just a little bit under 10 trillion kilometers. So a very significant distance. We use a diagram called a Hertzsprung-Russell diagram, or abbreviated HR diagram, to classify our stars into different groups. And the way that we use this HR diagram is by looking at the luminosity, or the stellar brightness, and the temperature of each star. So when we look at this diagram, along our x-axis is the temperature of the surface of that star, and I accidentally cut it off, but if we could see the y-axis, this would be the absolute magnitude, or the brightness of each star. So when we do this, we're going to be able to group different stars together based on these two different properties. We're going to get things like our supergiants, our giant stars, main sequence stars like our sun, and then finally our white dwarfs. If we look at our main sequence stars, which are found basically through the middle of this HR diagram, these make up 90% of all stars in our entire universe. And our sun is a good example of a main sequence star. It's going to be kind of a middle-sized star that has a middle length for its life. But in addition to the main sequence stars like ours, we also have what are called giants. And occasionally we just call them red giants because they're red in color. As you can tell from the diagram, these red giants are gigantic in size. They're very large and they're also very bright. They're very luminous. And we find them in the very upper right on our HR diagram. So we're going to have two different sizes here. We're going to have our red giants, and then we're also going to have supergiants. And even though they're gigantic in size, this makes up a very small percentage of all stars throughout our universe. But in addition to the red giants and the main sequence stars, the third main type of star are our white dwarfs. These are not as bright as our main sequence stars. They're fainter in their luminosity, and they're also a lot smaller. Most of them are about the size of the Earth, so they're nowhere near as large as a main sequence star, and definitely nowhere near as big as a red giant. But the name is a little bit counterintuitive because white dwarfs are not always white in color. They're just very, very small with low brightness.